Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how to solve exponential equations. An exponential equation is an equation in which the unknown is in the exponent position. So I've shown an example of an exponential equation here. And sometimes it's possible to solve exponential equations without getting into logarithms. I could do that in this situation because I can express 4 as a power of 2. I can express 8 as a power of 2. And when you can express your numbers with the same base, then it's much easier to solve the equation. So I could write 4 as 2 squared. I could write 8 as 2 cubed. My laws of exponents say that this is equal to 2 to the 2x. So if 2 to the 2x is equal to 2 cubed, the only way that can be true is if the exponents are equal because the bases are equal. So I would get 3/2 as a solution. Now, most exponential equations are not going to be able to be solved that way, so we need a strategy. And we're going to use that strategy on this example. So you can see that we'll get the same result. The strategy involves taking the logarithm of both sides of the equation once the equation is simplified. And you either use base 10 or base e. So we're going to take the log of both sides, base 10. So we'll have log of 4 to the x equals the log of 8. The reason I want to do that is I need to isolate my x, and I can't isolate it when it's in the exponent position. I can isolate it if I go into log notation, but my calculator doesn't have log base 4 on it. So I need to use a base that my calculator has, which is base 10 or base e. My property of logs allows me to get the x out of the exponent notation and write it in front as a coefficient. So this will be equal to the x times the log of 4. All right, so that's the third property of logarithms I used, which I talked about in the video on properties of logarithms. Now I have x times some other factor. I can isolate x by dividing by that other factor. So I'm going to divide this side by the log of 4. I'll do the same thing to the other side. Now that I have x isolated, I can do the calculation. And instead of, finding the log of 8, writing it down, finding the log of 4, writing it down, I try to do all my calculations all at once and just give the final answer. So if I take log of 8 and divide by log of 4, I'm going to get 1.5, which we know is the answer from doing it previously. Would I get the same result if I used base e logarithms? Let's check. So if I took the natural log of both sides, I can still use my third property of logarithms to bring this x out front. So that will be equivalent to x times the natural log of 4. Now I want to isolate for x, so I divide both sides by the natural log of 4. And if you punch that into your calculator, natural log of 8, divide by natural log of 4, you indeed will get the same result. Let's take a look at some more examples. If your equation has base 10 or base e, that should tell you what type of log to take of both sides. In the previous example, I could do base 10 or base e, but if the base is 10, then I'm going to find the log of both sides base 10. So that's what I'm going to do in this situation. I'm going to take the log of both sides base 10. You may or may not remember, one of our properties of logs says that if we have the log of b to the n and our base is b, that will simply be equal to n. Because we're saying what must b be raised to equal b to the n? Well, it must be raised to the nth power. That's what we're dealing with here. My base is 10, so I'm saying what must 10 be raised to equal 10 to the 3x? That's just going to be 3x. If you want to think of it as 3x times the log of 10, and then understand log of 10 is equal to 1, that's another way of thinking about it, so 3x times 1. Either way, the log of 10 to whatever will equal that whatever, okay? And then we have log of 75, which I'll calculate in a few minutes. Now I can solve for x by dividing both sides by 3. I do not divide 75 by 3. I divide the log of 75 by 3. So I find the log of 75, divide by 3, and I get an answer of 0.625. My next example is base e. So in this case, when I take the logarithm of both sides, I'm going to take the natural log of both sides rather than the common log. I'm going to use base e. But before I can take the log of both sides, I need to deal with this coefficient. It's going to get very complicated if I take the natural log without doing the simplification. So what I'm going to do is just divide both sides by 2. So I will end up with e to the negative 2t is equal to 0.8 divided by 2, which is 0.4. So do any simplifications that you can so that you just get your power, your base with your exponent on one side, and then some quantity on the other side. Now that we've simplified, now we're going to take the natural log of both sides. So the natural log of e to the negative 2t will equal the natural log of 0.4. Again, we're using this property. If we are finding the log of b to the n and our base is b, which is the case here, I'm finding the log of e to the negative 2t and my base is e, that result is just n. So it's just going to be negative 2t equals a natural log of 0.4. Some people might think of it as just going from exponential to log notation, and that's exactly true. But some people have trouble with that, so stick with taking the log of both sides every time. It's, again, a preference. Now I can solve for t by dividing both sides by negative 2. And I get a final answer of 0.458. Okay, this next example is actually a compound interest formula if the money was compounded at 5% annually. Again, none of that's really that important. We can still solve this whether we understand that or not. And the question asks us to find t, so our unknown is in the exponent, so that means it's an exponential equation. If p is 1,000 and a is 2,000. So in other words, we're going to find how long it takes for $1,000 to turn into $2,000 if the interest rate is 5% compounded annually. So we plug in 2,000 for a, 1,000 for p. Common mistake that I see students do is they multiply these two. Can't do that. This has an exponent, so you cannot multiply it by anything. It doesn't work. What you need to do is get that 1.05 to the t power by itself. In order to do that, we're going to divide both sides of the equation by 1,000. So again, we're simplifying before we start taking the log. So just do any simplification that you can first, and then proceed with the strategy. So I'm going to divide by 1,000 and I get 2. Now it's a simple exponential equation. I'm going to take the log of both sides. It doesn't matter if I do use base 10 or base e. I'll use base 10. So the log base 10 of 2 will equal the log base 10 of 1.05 to the t. My third property of logs allows me to bring that t out front. And then to solve for t, I'm going to divide the log of 2 by the log of 1.05. When I do that, I get an answer of 14.2. T is going to be in years in this example, so it would take 14.2 years for my money to double. given that interest rate and that timeline for compound interest. Okay, our last example deals with population growth, and this formula is often used to model or represent population growth. So it could be a country population growth or a city or whatever the population is. It could be an animal species and so on. P represents the population at time t. P sub 0 represents the population at time 0, so when you start, so the initial population from the time you start. R represents the rate of population growth for that species or country or city. And T represents the time. If the growth rate is per year, then the time would be per year. If the growth rate is per month, then your time is going to be per month in number of months. So let's take a look at this example. It says find T if P sub 0 is 37.5 million, R is 1.4%, and P is equal to 40 million. So let's say we're talking about Canada and we want to know today, 2020, our population is 37.5 million. We want to know how long will it take for Canada to reach 40 million if the growth rate in Canada is 1.4%. Now, before we put R into our formula, we have to change it to a number without the percent sign, so we divide by 100. So R will be equal to 0.014. So let's plug in our values. We have 40 million equals 37.5 million. E to the 0.014 t. I don't want to start dealing with logs at this point. I want to simplify. So I'm going to divide both sides by 37.5 million. When I do that division, it's not a nice even number. It's a long decimal value. And I don't want to start rounding off at this point. So instead of doing the division and writing it as a decimal, I'm going to just reduce this fraction, and it will be 16/15. And that way I can keep it exact. I just want to keep it as an exact value, and I don't want to keep this whole big value. So I just did a bit of reducing. Now that I have it simplified, now I can take the log of both sides. My base is e, so I'm going to take the natural log of both sides. One of my properties of logs tells me that this is just simply equal to 0.014t. Now I can divide or so isolate t by dividing by 0.014. Now I can use my calculator to solve, punch everything into my calculator, and I get 4.61. So in this case, if we were talking about that rate in years, it would take 4.61 years for a country that has this population to grow to this population if the growth rate is 1.4%. So that gives you an idea of how to handle exponential equations. Again, you need to practice this. You need to do as many different ones as you can to develop your skill and your confidence. Take care and see you on the next video.